Good afternoon, students. Myself Naresh Reddy, and I'm going to take this session for you, the GTQ session, gate through questions. The subject is communication systems. As you know, the subject communication systems is the main core subject for electronic students, EC students. Okay, and from last couple of years, the minimum of 10 marks they are giving in gate examination. So we expect at least of 10 marks in the coming gate examination also. And I will take up some questions, some good questions, okay, and possibly I'm expecting like this model of questions, okay, we can expect in the coming gate examination. So in that way only I framed the questions. So I framed the questions like some simple questions, some moderate questions, some tricky questions also there. And so I hope this session is definitely gonna help you in the coming gate examination. Yeah, fine. Let's start with the questions. Let's dive into the questions, and this is the first question I'm taking here. So if you read the question, meanwhile let's approach like this. You can start solving this question on your own also. When I'm giving a question, you can start solving that question on your own. Yeah, of course I'm here to help you, okay, but even you also can try from your end. I think this is visible to you. Yes, okay, and give your answers in the chat box, and I'm seeing your responses here. I will see your responses in the chat box. Yes, so let me read the question for you. The input signal applied to PCM has a maximum frequency of 4 kHz. So the maximum frequency of the message signal I'm denoting with F max. Okay, and the input range varies from minus 4.8 volts to 4.8 volts. So the amplitude range of applied signal varies from minus 4.8 volts to 4.8 volts. Okay, the average power of input signal is 30 milliwatts. Average power means simply you can understand that is power only, the power of the input signal. So whatever the power we find for a signal, that is the default, will be called as average power only. Okay, so the power of the input signal is 30 milliwatts. The target output SNR is 20 dB. So the SNR required is 20 dB. So S by N, it is required is 20 dB. S by N means you can understand this noise power here, quantization noise power only you can understand. So when we talk about PCM system, okay, the S by N what you see, you have to understand that as signal to quantization noise power ratio only, even in examination also. Okay, so whenever the question is framed for PCM, and if you see SNR, that SNR you have to understand as signal to quantization noise power ratio only, you have to understand. Yes, for my convenience I'm writing this as S by NQ, 20 dB. If you write in normal में आप लिख दिया तो इसको, what is the corresponding normal value will be 10 power 2, that is 100. In dB, that is 20 dB, the corresponding normal value will be 100. Assume uniform quantization and the PCM produces binary output. Okay. What is the quantization employed here is the uniform quantization. How to understand uniform quantization? If each step size is same and middle of the step is selected as a quantization voltage, then that quantization, yes, we can call as uniform quantization. Okay. Means each step size will be same delta and middle of the step is selected as a quantization voltage, then that will be uniform quantization for you. The step size is different hai to that comes under the category of non-uniform quantization. Minimum number of bits required to represent each sample will be. So here The number of bits per sample I'm denoting with n, so we have to find n minimum, we have to find out. Okay, so I can say S by NQ, target SNR is 20 dB. No? Okay, so S by NQ is 20 dB, that is 100. If you see the signal power is how much here? Yes, the average power of the input signal is 30 milliwatts. So that is simply the power of the input only. So how much this is? 30 milliwatts. 30 into 10 power minus 3 watts. Yes, I am expecting answers from you. Do solve this question. Yeah, good afternoon, Ishita. Good afternoon. So Ishita is saying 7. The answer is 7. So let's check this. Okay, whether that is correct or not. Let's check that. What about others? You are getting the same answer 7 or any other answer you are getting? Fine. Now NQ will be equals to, yes, NQ will be equals to delta square by 12. Yes, for uniform quantization के लिए, okay, quantization noise power will be delta square by 12, where delta is the step size. Delta you can write as the peak to peak upon 2 power n. This is, or peak to peak upon 2 power n you can write as L only, you can write, that is L. Yes, he is expecting n from us, so you can write 2 power n also directly, that's your wish. And peak to peak voltage will be how much? 9.6 volts. Okay, the amplitude of the signal varying between minus 4.8 and 4.8, the peak to peak voltage I can say 9.8 upon 2 power n. So this S by NQ will be equals to now delta square by 12. So if you go for square of this is 9.6 square 2 power 2n into 12. So it is delta square by 12. Okay, then yes, S by NQ, S is signal power is 30 into 10 power minus 3. Okay, NQ will be this much. NQ is 9.6 square upon this is 12 into 2 power 2n. This is, and it should be equals to how much here? 100. So this is 30 times 2 10 power minus 3, and if it goes to the numerator, this is 12 into 2 power 2n upon 9.6 square is equals to 100. Okay, so if you try to solve the n value, try with calcium. N value you will get 7.32 is what you will get. This is what you are getting, n value? What is the n value you are getting? Try with calcium. Yes, this is, you should be good in calculations. And it's all about how fast you are in calculations. Yes, 7.32. Then what is the n? What is the answer you have to go with here? So here options may, if you see 6 is given, 7 is given, 8 is given, and 9 is also given here. So here S by NQ, I can say should be at least of 20. We always look for S by NQ should be as high as possible. We always look for that. I can say, so for that S by NQ should be at least of this much, I can say. So S by NQ should be greater than or equals 20 dB, I can say. Greater, because n must n should be an integer, each sample represented by how many bits. Then I can say n should be greater than or equals 7.32. Okay. So in satisfying this, okay, n should be integer, at the same time this condition also should be satisfied. So I can say n minimum equals to 8. N greater than or equals 7.32 means you can go for 8 and 9 also here. With the options may 8 is given, 9 also given, but I have to go with the answer 8 here, because if n is very much of high, then channel bandwidth requirements also increased. That is definitely going to be a problem. Okay, so you have to maintain the trade-off between S by NQ and the bandwidth requirements. Okay, as n increases, S by NQ will be increased, that is something good. But at the same time, as n increases, channel bandwidth requirements also will be increased, and we always look for the channel bandwidth requirement should be as minimum as possible. So here S by NQ should be, okay, at least of 20 dB we have to maintain here. Okay, because if you go for n equals 7 here, if n equals to 7 if you take, then this condition is not going to be satisfied. Then you will get S by NQ less than 20 dB only. S by NQ you will get less than 100 you will get if you take n7. But if you take n8, then definitely S by NQ is, yes, you will get greater than 100 is what you are going to get. Okay, yes. And here you can go for n8 and 9 also, okay, will satisfies this requirement. Okay, but to make the channel bandwidth requirements to be minimum possible, so I will go with n equals to 8. So this condition should be satisfied, at the same time n should be integer. So what is the minimum n value we can go for is 8. So option C is going to be correct here. Okay, option C will be correct. So Arif Khan is saying some noise is there in the voice, noise is there in the audio. What about others? You're getting any noise or the audio is clear? Tell me. So we'll go for the next question. Yes. So this question is about delta modulation. Yes. Let me read the question here. A linear delta modulator is designed to operate on speech signal which is limited to 3.2 kilohertz. Okay, so here a delta modulator is designed to operate on this signal, speech signal, which is band limited to 3.2 kilohertz. The delta modulator operates at sampling rate of 10 times to Nyquist rate. Okay. Yes, sampling rate is equals to 10 times to Nyquist rate. Yes, Nyquist rate I can write 2 FM. So this is 20 FM. This is, and FM is equals to what here? 3.2 kilohertz. So this is 20 times to 3.2 kilohertz. And this is, I can say, 64 kilohertz. This delta modulator is designed to operate on this signal whose frequency is 3.2 kilohertz, and the delta modulator is designed such that the sampling rate is 10 times to the Nyquist rate, that is 64 kilohertz, and delta is given 100 millivolts. Fine. Now the modulator is tested with a 1 kilohertz sinusoidal signal. Okay, actually here delta modulator is designed to operate on this signal which is band limited to 3.2 kilohertz. That's fine, but this delta modulator which is designed to operate on this signal, okay, उस डेल्टा मॉड्यूलेटर को आई एम गोइंग टू टेस्ट विथ सम अदर सिग्नल. So we already designed the delta modulator. They already designed the delta modulator. Okay, design किया है, and that delta modulator now I'm going to test with some other input signal. And what that other input signal? So that is 1 kilohertz sinusoidal signal. Okay. So what is the frequency of the signal is? I'm denoting with Fn. Okay. So this is, if you take delta modulator, you see, it is actually designed to operate on the signal which is having the bandwidth of 3.2 kilohertz. Okay. And for this delta modulator, what is the sampling rate? Sampling rate is maintained is how much? 64 kilohertz. And what is the delta for this? The delta which is maintained is 100 millivolts. So 100 into 10 power minus 3 volts. Now this delta modulator which is already designed is tested with some other input signal. And what is the frequency of that applied input signal now? The frequency of the applied input signal is 1 kilohertz. Okay, 1 kilohertz sinusoidal signal. The maximum amplitude of the test signal required to avoid SOE is dash volts. It is a applied signal is a sinusoidal signal, and whose amplitude is, I'm denoting with AM, and the frequency is 1 kilohertz. Actually this delta modulator is actually designed to operate on some other signal, is designed to operate on some other different signal whose bandwidth is 3.2 kilohertz. So that the delta modulator, okay, yes, we supposed to expect that, okay, no SOE and no GE. When this delta modulator is operating on the signal, then we expect that no SOE and no GE. But this delta modulator which we already designed here to deal with some other signal, okay, now this delta modulator I am testing with some different sinusoidal signal I am testing with. Okay, because if I am testing with some other signal, there might be chance for SOE and G, because I already designed this to deal with some other signal, I designed it. But I am testing this delta modulator with some different sinusoidal signal here, then there might be chance for SOE and GE now. Okay, then what is the question here is, what is the maximum amplitude of the, okay, sinusoidal signal required? Okay, sinusoidal signal का maximum amplitude कितना होना चाहिए उससे, okay, amplitude of the sinusoidal signal, okay, should be within some limits only. Okay, then only we expect that no SOE. And here the question is, what that maximum amplitude of the sinusoidal signal required to maintain to avoid SOE, we have to find out. Okay, anyone? Yes, Chinmay is saying 1.01. I can recall these names. Okay, most of you are from online batch, I think, no? Online students. So I can recall your names: Chinmay, Ishita, Saptarshi, Biswas. So most of you giving the answer 1.01. So let's check whether this is correct or not. Saurabh is also saying, yeah, Achrekar. How is Saurabh? Yeah. How are you? Chinmay, Aryan Mukherjee. Yeah, 3.2 upon pi. Yeah, that is also equals 1.01 only, no? I think. Yes. Now, yes, to avoid SOE, delta by Ts should be greater than 2 pi FM AM. Yes, the applied signal here is the sinusoidal signal. Okay, when the sinusoidal signal is applied, then to avoid SOE, this is the condition to be satisfied. Okay, delta by Ts should be greater than this. Means the slope of the reconstructed signal, delta by Ts, even should be higher than maximum possible slope of the original message signal. Okay, maximum possible slope of the sinusoidal message signal is of course 2 pi FM AM. Students, if you try to recall, if this condition is satisfied, then definitely GE is going to occur over entire time axis. only the error GE is going to occur if this condition is satisfied. At every of the time instance, the only error which occurs GE means, okay, there is no chance for SOE, I can say. Means if this condition is satisfied, there is no chance for SOE. आपको देखने के लिए SOE किसी भी time instant पर भी ही नहीं मिलेगा. Okay, you don't find SOE at any of the time instance. Okay, yes. So it is delta. TS is 1 upon TS is Fs. Okay, 2 pi Fm AM. Delta is how much is given, 100 millivolts now. So 100 into 10 power minus 3. And Fs is how much here? 64K. I am writing 64 into 10 power 3 greater than 2 pi. This is Fm. This is tested with the sinusoidal signal having frequency 1 kilohertz. So Fm is equals to 1 kilohertz, or I can say 10 power 3 AM. So I can say AM should be less than, okay. So this is 10 power minus 3 and 10 power 3 will get cancelled. Yes, this is 640 upon this is 2 pi into this is 10 power 3. So AM less than, it is 1.01 you will get. This is. So this is some of you given the answer 3.2 upon pi, but this is you can check this is numerical answer type question. So what is that numerical value we get? That numerical value we have to substitute here. So what is this value will be? 1.01 no? Yes. I am doing calculation along with you only. The calci I am using now. Okay. So 0.101 it is getting. So how much it is? 6400 this is. Yeah. Yes. 6400. I written 640 na. So 1.01. So what is the maximum amplitude? So to avoid SOE, the amplitude of the sinusoidal signal should be less than 1.01 volts, I can say. This is. So what is the maximum amplitude of the applied signal allowed is 1.01 volts. So this is 1.01 will be the answer. Okay. If you round off to 1 decimal place, there is simply 1 volt only. If the question may it is given round off to 1 decimal place, then 1 volt will be the answer. Okay. Yes. 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 Fine. Let's proceed to the next question. This question also I given based on delta modulation only I given. A modulating signal means message signal only. Okay. A tan h beta t. So it is hyperbolic tangent function A tan h beta t. So this is the message signal given to delta modulator. Given delta is 1 millivolt and Fs, the sampling frequency is 8 kilohertz. The maximum value of A required for no SOE is. It looks to be similar to previous question only, but difference to hai, the difference is there. In the previous question, the applied signal is sinusoidal signal, but here the applied signal is not a sinusoidal signal. Okay, it is not going to be a sinusoidal signal, it is some other signal here. Okay. Now, what is the maximum A required for no SOE? We have to find out. This is MCQ question, multiple choice question. Anyone? Can you give the answer for this? Yes. Yes, let me write to avoid SOE. Now you have to use the general formula in terms of m of t, general formula. Yes, to avoid SOE, the slope of the reconstructed signal even higher than maximum possible slope of the original message signal. Should be even higher than maximum possible slope of the original message signal. If this condition is satisfied, everywhere GE is going to occur at every of the time instants, then there is no chance for SOE, I can say. Yes, delta 1 by Ts is Fs, differentiation of MT. What is the differentiation of A tan H beta T? So this is A. What is the differentiation of hyperbolic tangent function tan H? That is secant square. This is H beta T. This is secant H square beta T. This is and maximum. And substitute the values here. Delta is how much? 1 millivolt, that is 10 power minus 3. Fs is 8 kilowatts. 8 into 10 power 3. This is, and this is here. What is the differentiation of this argument? What is the differentiation of beta T? I have to write this also, that is beta. Okay. Max. So this is A beta secant H square beta T maximum. So most of you saying option D. Yes, Saurabh, Hari, Sakshi, Rishabh, Ishita, Ashish. Yeah. Yes, what is the maximum value possible for secant H function? If you see secant Hx, if you plot a graph of this is secant Hx versus x. So it is going to be like this. It almost looks like a Gaussian function, and this is 1. This is. So what are the values possible for secant Hx? Secant Hx takes the values between 0 and 1 only. It takes the values between 0 and 1. Secant Hx. Yes. And the maximum value possible for secant H function will be 1 only. The maximum value possible for secant H function, where at the origin we expect the maximum value. So what is the maximum value possible for, okay, at different time instants for different beta values? Secant H beta of t will be taking different of values for the given beta at different time instants. So secant H beta of t will take different of values, but the maximum value possible for secant hyperbolic secant function will be 1 only. Then the maximum value possible for, okay, secant h square beta of t is also 1 only. So this is 8 greater than, so the maximum value possible for this is 1, so a beta this is, okay. So all the options are okay. A by default we take positive only, okay, and all the options you can see will be given positive values only, it is given. So beta also the default you can understand some positive value only, so modulus of a beta will be a beta only, okay. Then a should be less than 8 upon beta, then a max will be equals to 8 by beta, 8 upon beta. So option D is going to be correct. As most of you given correct answers, good. I'm happy like your preparation, okay, done to some good extent is what I'm feeling like, because most of you giving correct answers. That is something good, that's a good sign. If you see this question, try to read that question. Yes. The binary data is transmitted over AWGN channel at the rate of 5 kbps. Okay, so the bit rate is given, RB is equals to, the single sided PST of the channel noise is 10 power minus 7 watts per hertz. It is AWGN channel, it is mentioned, and the power spectral density of the channel noise is 10 power minus 7 watts per hertz. So that is that to one sided. So one sided means that is N naught. Will be, yes. Bit energy is 2 times to 10 power minus 6 joules. So it is EB. Average bit error probability for non-coherent, okay, you should be careful about this, for non-coherent binary FSK is, so here this question is about, we have to find probability error of non-coherent BFSK. Binary FSK means normal FSK only. So what is the probability error for coherent FSK के लिए? Coherent FSK के लिए Q of root over EB by N naught. This is for, it is coherent FSK के लिए. But we have to find for non-coherent FSK. So whenever the question you have to find average bit error probability. Bit error probability means simply probability of error only. Average probability of error means simply you can understand that as probability of error only. Don't give any importance to average. Okay. Yes. And what is the probability error for non-coherent FSK? Anyone remember? This is half e power minus EB upon 2 N naught. This is, yes, no? Yes. And if you substitute here, this will be half into e power minus EB. It is simply formula based question. 2 times to 10 power minus 6 upon 2 N naught. N naught is how much? 10 power minus 7. So 2 will be cancelled. Half times 2 e power, this is minus 10. Minus, it is 10 power 1, no? This is, yeah, 10 power minus 6 plus 7, 10 power 1 only. So half e power minus 10. So what is the answer you have to go with? So this is e power minus 10. So 0.0000226, this is so to match with the given options, in matching with the given options, you can write this as 2.26 into this is 10 power minus 5. This is, so option A is correct here. Yes, Sakshi Agarwal, Barik, Ishita, Rishabh, Chinmay, your correct answers. If you see the next question, yes. So this question is about Huffman coding. This is a discrete memoryless source generates 3 independent message symbols with probabilities of, okay, a source here is generating 3 possible symbols and the corresponding probabilities are given here, and the compression ratio with Huffman coding will be, we have to find out. So compression ratio, I want to introduce this parameter, compression ratio. Yes, in source coding, like if you take the source, the source is emitting 3 possible symbols. Yes, I am denoting with x1, x2, x3 like this. Okay, so 3 symbols available here source के साथ x1, x2, x3, and this is generating these 3 possible symbols in very much of random sequence. It is generating, and इस symbols को हम transmit करना है, and symbols को transmit करने के लिए first we have to do coding. Means each of the symbols we have to represent with unique binary codes, and the resultant binary sequence will be transmitted. And to do the coding to the symbols, we take the help of source coding techniques. The famous source coding techniques will be Shannon-Fano coding and Huffman coding. And here the coding which we have to use is Huffman coding. Now, what is the compression ratio? In the process of coding of symbols by using a source coding technique, how to find the compression ratio is, anyone come across this? So this is average code length. The formula is average code length without compression upon, this is average code length with compression, without compression and with compression. With compression means with this coding only, means by performing Huffman coding, what is the average code length we get? That is average code length with compression. Average code length without compression means, okay, without compression means that is simply you can understand as pixel length coding only. Without compression means you can understand this is fixed length coding. Means in pixel length coding, each symbol represented by same number of bits. Every symbol represented by same number of bits. Okay, but this with compression means using source coding technique. Using source coding technique. देखो in source coding में we do coding based on the probabilities. Yes, no? Then different symbols represented with okay, different binary codes, and the length of that binary codes also going to be different, because here the coding will be done based on the probabilities here. Okay, and the source coding techniques comes under the category of variable length coding. Yes, if you do that variable length coding, definitely the average code length is going to be decreased. Averagely each symbol represented by how many bits, that will be decreased. That is the advantage with compression, that is advantage by performing source coding technique. The average code length will be minimized. Okay, so if you see what is the average code length with fixed length coding, this is, anyone, can you tell me? Yes, you can see without compression L will be equal to the average code length. I am denoting with L without compression. Here three symbols hai. To do coding of three symbols we need three binary codes. To generate three binary codes we need at least of 2 bits. With the help of 1 bit only 2 codes we can generate, 1 and 0. With the help of 1 bit. Okay, so to generate 3 binary codes we need at least of 2 bits. With the help of 2 bits 4 binary codes are possible. Okay, among these 4 binary codes available, so I will take 3 binary codes we will do to do coding. So we will discard 1 code. So among the 4 codes available हम 3 codes को use कर सकते हैं to do coding of the symbols. So altogether, okay, without compression, averagely each symbol represented by how many bits is 2 bits I can say. So it is 2 bits per symbol. Okay. Now with compression we have to find out. With compression means what is the average code length we get after performing this Huffman coding. Okay, let's do this Huffman coding. How to do Huffman coding? First we have to arrange the probabilities in decreasing order. Already probabilities given in decreasing order, so arrange in the same order. So 0.9, so this is 0.08 and 0.02. So this is probabilities in decreasing order. And what are the corresponding symbols? Xi, so x1, x2 and x3. Yes. How to do coding? Yes, in the source coding techniques the coding will be done based on the probabilities. So first you have to add the least 2 probabilities को up add करना है. So it will be 0.1. This is. Now this. Yes. Now ignore these 2 probabilities. No. Now these 2 probabilities what you see here 0.9 and 0.1 you have to arrange them in decreasing order. You have to arrange them in decreasing order. This is. These 2 probabilities ko we have to arrange in decreasing order. So 0.9 still in first place only, and this is 0.1. This is. So you can stop here where you left with 2 probabilities. Okay, you can stop here. Of course, if you add these 2 probabilities, you will get 1. Total probability of course will be 1. Now, so this least 2 probabilities which were added, associate 0 and 1 for them. 0 and 1. You have to associate 0 and 1. Now, what is the code that will be generated here? This is. I can write here what is the code that will be generated. So what is the code for x1? What is the code for x1? So simply try to reach to the last step. Then what the bits we come across? Only 0. Okay, so x1 coded with 0. What about x2? So what is the code for x2? So from this 0.08 try to reach to the last step. This is. In reaching the last step, what the bits you come across? 0 and 1. But you have to take this code in reverse order. That is a standard procedure we have to follow. Why we have to take in reverse order is to make this code prefix free code. This is the procedure we have to follow. If you take in reverse order, this is 1 0. And what is the code for x3? x3 के लिए code क्या होगा? Yes, try to reach to last step. So this is, what is the code? 1 1. Even if you take in reverse order, that is 1 1 only. Yes. So this is 1 1. Yes, you can see it is variable length coding. The code words length is different here for different symbols. Now if you find the, yes, if you see code length ni, number of bits in the code, this is 1 2 and 2. That is the code length of given symbols. Then how to find the average code length? Summation. I specifies how many different symbols are associated, okay, and code length of each symbol multiply with corresponding probability. So code length of each symbol multiply with corresponding probability. So 1 times 2.9 plus 2 times 2.08 plus 2 times 2.02. And if you do this, so what it will be equals to? This is, so this is 1.1 is what you will get. This is 1.1 bit per symbol. So this is the advantage what you see by performing source coding. If you do coding with the help of source coding technique, the average code length will be decreased. 1.1 bit per symbol, you can say, bits per symbol. Without compression, each symbol represented with 2 bits, but after compression each symbol represented by 1.1 bits. It is something good. Okay, then what is the compression ratio? Compression ratio. So this is 2 upon 1.1, and I can say 20 upon 11. So which option is correct here? 20 upon 11. The option A is correct here. Yes. So if you see the next question, yes, try to read that question. Now here, yes, consider a systematic LBC, okay, with parity check equations are given like this. Here the parity check bits are given. So what are the parity bits here is P1, P2, P3, P4. These are the parity bits, you can understand, and M1, M2, M3, M4, these are the message bits. So how many message bits you can see? Okay, M1, these are the message bits you have to understand. M1, M2, M3, M4 hai. 4 message bits. Okay, number of message bits, means each message block having how many bits? 4 bits. Number of message bits in each message block, I can write like that better. Number of bits in each message block. K, that is 4. And how many parity bits? Parity bits also 4. Number of parity bits. Number of parity bits we denote with n minus k, that is also 4. Number of message bits 4 and number of parity bits, okay, is also 4. Then number of bits in each code word, in each code word n will be, each code word will have how many bits in it, so that will be 8. So it is, I can say n comma k lbc, no? N comma k lbc, and I can say this is 8 comma 4 lbc, this is 8 comma 4 lbc. Now we have to find d min for the given lbc. d min हम find करना है. So one way to find d min is smallest possible minimum distance. Basically d min is called as minimum distance. How to find d min for lbc is, it is the smallest possible minimum distance. D min is minimum distance for the given lbc. What is minimum distance? Is smallest possible Hamming distance, smallest possible Hamming distance between any possible pair of code words, between any possible pair of code words, smallest possible Hamming distance will be d min, okay, and that is very time taking process, okay, to find based on this definition, finding d min. इसलिए I given another procedure to find d min. What is that procedure? Is smallest possible Hamming weight of non-zero code word, smallest possible Hamming weight of non-zero code word will be equals to d min. But here this procedure also going to be a time taking process, okay, because first you have to get all possible code words. We have to get how many code words we can expect? 16 different code words we expect, because each message block having k bits in it. How many distinct message blocks possible? 2 power k, 2 power 4, that is 16 different message blocks possible. 0 0 0 0 2 1 1 1 1, and for every of these 16 message blocks we have to get the corresponding code words. We have to get the corresponding code words, like these are the message blocks. If you see, if you denote with d, different data blocks or different message blocks, the corresponding code word C is equals to d into g. First you have to write the generator matrix. How to get the G matrix? G is equals to, you can write IKP transpose. The default is we keep the message bits in the first k places, that is the default of, the default G will be, we take IKP transpose. Once you got IKP transpose G matrix, so based on the G matrix you have to get the code words. So once you got that 16 different code words, for every of the code word you have to find Hamming weight. How to find the Hamming weight of a code word? That is simply the number of ones, okay, number of ones in the code word, okay, code word में कितना ones है, that will be, okay, Hamming weight for us, number of ones in the given code word. So you have to find Hamming weight of every of these code words. What is the minimum possible Hamming weight we will get for non-zero code word? That will be d min. But this is also a time taking process, getting 16 different code words. It is also time taking process. इसलिए और एक shortcut है to find d min. I want to give you that shortcut. Yes, from H matrix say, if you have the parity check matrix with you, so from this H matrix say you can get to d min directly. You can get d min based on the H matrix, okay. Yes, first let's get this P, parity matrix. Parity matrix. Darshan is saying, sir, in QRC nice is not there, I guess, so it is wise to skip that part for the examination. Nice is not there. Which topics of nice is not there, Darshan? Be specific, like which topics not there in QRC? Which specific topic of nice? It is about finding probable error of ASK, PSK, FSK you are saying? Like finding optimum threshold voltage and finding probability error, the correlator based receiver, matched filter based receiver. This is what you are saying? Is those topics are not there? Which topics are not there? Give me that specific topic names which you haven't found in QRC. First let me know that. P will be. How to get the parity matrix? Okay. So from these equations for the parity bits, you can write parity matrix. Yes, in this first equation, M4 is missing. M4 is missing means this is 1, 1, 1, 0. Simply the coefficients of this data bits, the coefficients of message bits will becomes the elements of the parity matrix. Here M1 is missing now, so M1 is missing. So it is 0, 1, 1, 1. And here M2 is missing. M2 is missing means 0, 1. This is M2 is missing now, yeah. 1, 0, 1, 1. And here M3 is missing. 1, 1, 0, 1. M3 is missing. This is the P matrix. Okay. So if G is IK P transpose, then what H will be? H will be, I can write here P transpose in the second part, here P will be in the first part. Here first part my identity matrix, that second part my identity matrix will be there, that is IM. M is of course N minus K, so N minus K will be 4. So P I4, IM means I4, this is. So if you write the H matrix now, yes, I am writing the H matrix, parity check matrix. P is, this is, yeah, 111 0 0 111 1 0 11 1101. This is, and I4 is 1 0 0 identity matrix. It is 0 1 0 0 1 0 0 0 0 1. This is. So it is H matrix. So from this H matrix we can get to D min. How to get D min is, okay, minimum number of columns of H, minimum number of columns of H, minimum possible number of columns of H that sum to 0, that sum to 0 will be D min, will be equals to D min. How to find from H transpose matrices? H transpose matrix से भी हम D min को find कर सकते हैं. D min को कैसे? That is minimum number of rows of H transpose. Minimum number of rows of H transpose that sum to 0 will be equals to D min. H से find करने के लिए what is the shortcut is minimum number of columns of H matrix that sum to 0. Okay, will be equals to D min. Yes, if you see, is sum of any two columns 0 here? If you take one column से start किया तो if you take any one column that is not 0, ठीक है. If you see sum of any two columns that sum to 0, sum of any two columns that sum to 0. If you take these two columns, if you see, yes, if you see these two columns, sum 0 becoming no. So 0 plus 1, 1, 0, 1 plus 0 is 1. Even if you go for sum of these two columns, is sum of these two columns 0, 1 plus 1, 0, ठीक है, 0 plus 1 is 1, okay, that is not correct. And even if you go for sum of these two columns, okay, not becoming 0. And even if you go for this, if you go for sum of this or this or this or this, not becoming 0. Okay, so sum of two columns, sum of any two columns you check is not becoming 0. Sum of any three columns is becoming 0. Sum of any three columns, if you see sum of these three columns is becoming 0, no, 1 plus 1 plus 1, that is becoming 1 only. Like if you see these three columns becoming 0, no, this is 1 plus 1 plus 1, 1 plus 1 plus 1 is 1, not becoming 0. Like that, sum of any three columns you can check. Like this is, if you see these three columns, not becoming 0. These three columns not becoming 0, 1 plus 1 plus 1. Sum of any three columns also you can check, that is not becoming 0. Any three columns not becoming 0. Sum of any four columns, if you check, sum of any four columns, that is becoming 0. Four columns, I think, will become 0. Check that. Any four columns. So if you see this three columns, if you add, okay, if you add these three columns, it is 1, but this is 0, 0, 0, but here it is becoming 1. But if you add with this, so 1 plus 1, even number of ones sum किया तो 0 ही मिलेगा. XOR addition करना है. Sum means that is XOR sum only, normal sum नहीं, XOR sum करने पर. Yes, if you go for sum of these 3-4 columns becoming 0 ना, so this is 0 0 0 है, fine, it's 0 0 0. Now if you see 1 plus 1 0 0 0, okay, and even if you see first element 1 plus 1 plus 1 plus 1 0. So sum of 4 columns is becoming 0. The minimum number of columns of H that sum to 0 is 4 here. Sum of any two columns, if you check any two columns, sum of any two columns not becoming 0. Sum of any three columns you check not becoming 0. Sum of 4 columns आप check करने पर becoming 0. So D min is equals to, okay, 4. 4, sum of 4 columns of H matrix is becoming 0. So D min equals to 4. So this is how we can estimate D min from H matrix. Okay, take care of this. Chinmay is saying is n minus k plus 1 formula is applicable here? Not applicable. Okay. Chinmay is saying from singleton bound, I said singleton bound D min is going to be less than or equals to n minus k plus 1. So if you see 8, 4 LBC, now this is 8, 4 LBC. For 8, 4 LBC के लिए D min is going to be n minus k plus 1. So n minus k plus 1 means 8 minus 4 plus 1. So D min is less than or equals to 5, I can say. Yes. So for 8, 4 LBC के लिए the D min what you can expect, that is definitely less than or equals 5 only. Okay. Depends on how you are designing 8, 4 LBC. How you are designing 8, 4 LBC. देखो इस 8, 4 LBC को डिजाइन करने के लिए what is the algorithm used here? This is the algorithm we are using to design this 8, 4 LBC. And for this algorithm के लिए, okay, we are getting D min equals to 4. But the D min what you got, yes, you can see it is satisfying this singleton bound, is satisfying singleton bound. But 8, 4 LBC, if you design 8, 4 LBC by using some other algorithm, okay, so we are using this algorithm, no? You can design 8, 4 LBC by using some different algorithm, then D min you are going to get different. Okay, but what singleton is saying is what may be the algorithm you are using to design 8, 4 LBC, the D min what you are getting will be definitely less than or equals 5 only. Less than or equals 5 only. There is no chance to get D min greater than 5. Okay. So singleton bound से we can find upper bound for d min. What is the maximum d min that is possible for n comma k LBC? Upper bound for d min we can find. If the question is for 8 comma 4 LBC, what is the upper bound for d min? I can say 5. Okay, but here ये design 8 comma 4 LBC design किया है with some based on some algorithm. Here this 8 comma 4 LBC is designed, and इस 8 comma 4 LBC के लिए d min क्या मिलेगा? Singleton bound is saying is d min less than or equals 5. Less than or equals 5 means वो 5 हो सकता है, 4 हो सकते हैं, 3 हो सकते हैं, 2 हो सकते हैं, 1 हो सकता है. And this 8 comma 4 LBC के लिए हमको क्या d min मिलेगा? We have to find that. कितना d min मिला है हमको? 4. Okay, it will be like that. Chinmay, I hope I give an answer to your question. Next, if you see this question. In mathematics also, I hope you come across such questions. The giant PDF of two random variables is given, fxy of x comma y, e power minus of x plus y, where x greater than or equal 0 and y greater than or equal 0 and 0 otherwise, and we have to find probability of x plus y less than 1. We have to find out. Okay, x plus y less than 1. How to get probability from density function area? Okay. Yeah, good afternoon, Sagar. Yeah. So which area will gives this probability? Okay, we have to find that. Yes. Graphically we can find this. Okay, how to find graphically is, this is, in mathematics I hope you come across this approach. So one way to solve this is, first x plus y you can assume some z, but this is time taking process. Probability of z less than 1 or z less than or equals to 1 you can write, because we are dealing with continuous random variables. Z less than 1, z less than or equals to 1 will not make any difference. How to get probability of z less than 1? So this is integration minus infinite to infinite fz of z dz. This is the area under density function will give you corresponding probability. How to get density where z is equal to x plus y, z is equal to x plus y. How to get the density function of z? I said the density function of x convolution with the density function of y. So first you have to get density function of x and density function of y. Yes, from joint density function से हम individual density functions को find कर सकते हैं. fx and fy you can find out. Yes, now how to find fx? fx of x from joint density function से how to get? This is fxy of x comma y. In getting density function of x, x remains unchanged. You need to do integration with respect to y, all values possible for y. So like that, first you have to get density function of x, density function of y, and you have to do convolution, then you get density function of z. Once you got the density function of z, so you have to find this integration that will give you probability of x plus y less than 1. But this is a time taking process. But if you go for the graphical approach, that will be much easier. So what is a graphical approach is? So just go for a quadrant like this. So it is, I can say, yes, it is x, you can take, and this is y. How to get probability from density function is area. So which area, okay, we have to find out to get this probability. We have to see that किस area को हम calculate करना है to get this probability. First, if you go for this line x plus y equals to 1, this is, what is this line equation? What is the, this is line equation only. What is that line will be x plus y equals to 1. X plus y, it is if you take the origin. This is. So what is that line equation? X plus y equals to 1. X plus y equals to 1. The line equation is this now. This is. Yes. So it is, this is the line equation of x plus y equals to 1. If this is 1 and this is 1. Yes, on this line equation, on this line p, okay, if you see corresponding x and y values and if you add them, you will get 1. If you see at this point y is 1, but what is the corresponding x value? 0. Okay, 0 plus 1 is 1. If you see this point pe, corresponding to this point x value, suppose 0.1 hai to this is, and corresponding y value is 0.9. So 0.9 plus 0.1 is 1, like that. So किसी भी point आप check कीजिए, okay, उस point पे x plus y का value 1 ही मिलेगा. Now x plus y less than 1 we have to find out. Okay, now you have to see what is that region of x plus y less than 1. x plus y less than 1 का region क्या है? किस region में आपको x plus y का value less than 1 मिलेगा? Less than 1 you will get. So I can say this is the area, this is. So this is the area for x plus y, this is the area, this complete area. This is, I can say, x plus y less than 1. This is. This region is x plus y less than 1. And this region hai na, this region, if you see this region. So this region, what you see, this region is going to be x plus y greater than 1, I can say, greater than 1. But this region is x plus y less than 1, this region is x plus y less than 1. Yes, even if you take some point here, if you see simply, if you take some point here, you can simply see like this. This point pe, suppose x value is 0 hai, correspond to this point x is 0, y is equal to some 0.1. So 1 plus 0 plus 0.1 is 0.1, x plus y is less than 1. If you take suppose this point, okay, x value to 0 hai, but y value is some 1.2. So 0 plus 1.2, that is 1.2. Okay, x plus y is becoming greater than 1 here, if you see. Okay, so yes. So here this point corresponds to x plus y less than 1. So if you take any point in this region, आपको x plus y value less than 1 ही मिलेगा. So this is okay. This region is corresponding to x plus y less than 1. How to get probability from density function area? अब क्या करना है कि to get this probability you have to find this total area को find करना है. This area, इस area को find करना है. You have to find this area based on this density function. Okay, how you can? Okay, you have to concentrate on this region. This region पे concentrate करना है to get this probability. To get this probability. So this is one way is x plus y less than 1. How to get probability from density function is area. This is double integration करना है dx dy. Graphically probabilities को find करने के लिए first you have to see which area corresponding to x plus y less than 1. So this is the area corresponding to x plus y less than 1. Once okay, this region you have to see what is the region corresponding to this x plus y less than 1 का region क्या है. So this region is corresponding to x plus y less than 1. Once you decided that region, you can easily find out this probability. How to get x and y limits? Okay, method 1 में okay, one way is you can fix x values को fix करके. So what are the corresponding to that fixed x value, what are the corresponding y values allowed, you have to see that. That is one way. Okay, x values को fix करके corresponding to those x values, what are the range of y values we expect. So based on that you can decide the limits for x and y. If x को fix किया तो I'm fixing x, Okay, what are the range of allowed x values here? 0 to 1. This is okay, x को fix किया मैंने. Okay, then what are the corresponding y values? So x को fix किया मैंने 0 to 1. And what are the corresponding y values? See this y values here, if you see, correspond to this point. So what are the range of y values we expect corresponding to this x value? X value 0 है, corresponding to this x value. What are the range of y values we expect? So your y also greater than or equal 0, you can see. No? Yes. Yeah. What are the corresponding y values we expect? These are the y values we expect, the range of y values. Corresponding to x is equal 0, these are the range of y values we expect. Okay, this y is from where to where? This is 0 to 1 here. Okay, y is equal 0 to 1. Okay, but corresponding to this x value को fix किया मैंने, that can be 0, 1, 2 like that. Corresponding to x equals to this, okay, x is suppose 0.1 I am taking, corresponding to x is 0.1. Okay, what are the range of y values? 0 to what here? 0 to what is this value? Okay, this value is going to be some 0.9 is going to be, okay, and if you take x value, suppose 0.5, x value 0.5, corresponding to this x value 0.5, what are the range of y values here? The range of y values is 0 to 0.5 and x 0.9 के लिए. Okay, what are the corresponding y values? 0 to 0.1, 0 to, this is 0 to 0.1. Okay, let me generalize this. How we can generalize is, so what are the corresponding y values is, it is 0 to, yeah, what are the range of y values we expect here? Range of y values we expect depends on definitely x क्या है. Okay, x value 0.1 है तो y the range we expect 0 to 0.9, x 0.5 है तो range of y is 0 to 0.5, x 0.9 है तो the range of y is 0 to 0.1. Okay, so what are the range of y values we expect depends on x, definitely depends on x. So what are the range of y values expect is 0 to, ये तो definitely it starts from 0, 0 to I can write x minus 1, depends on x. No? So what is this point? Okay, so corresponding to this point, what is the y value? Corresponding to this point, y is equal to, I can say, x minus 1 only. It is x plus y is equals to 1 corresponding to this line. Okay, इस line पे किसी भी point पे आप y value देख लीजिए, that y value is going to be x minus 1 only. किसी भी point आप check कीजिए इस line पे y value will be 1 minus x only. Okay, if you see x 0.1 है, corresponding to x, okay, what is the y value? Y 1 minus x, no, 1 minus 0.1, that is 0.9. For here at this point, what is y? Y is equals 0.5 only, 1 minus x. So here corresponding to this x value, what is y here? 1 minus x. 1 minus 0.9 is 0.1. So y I can say 0 to 1 minus x. Okay, so this is, you can write the probability of x plus y less than 1. What are the range of x values? 0 to 1 I can say, this is. And what are the range of y values? This is 0 to x minus 1. And what is this giant density function is? E power minus x plus y. This is dx and dy. Of course, you can see in this region may x greater than 0, y also greater than 0, you can expect x greater than 0, y also greater than 0. This is one way. Yes, and you can do like this also. Method 2 में you can do in method 2. Method 2 में y को आप fix कर सकते हैं. What are the range of y values we expect? The range of y values will be 0 to 1. This is, it's like this. This is. Okay, y को fix करने पर what are the range of y values here? 0 to 1. Okay, and what are the corresponding x values? For the given y values, what are the range of values we expect for x? Okay, same like, what are the range of, for the given y? If for example y 0 है तो okay, what are the corresponding x values here? 0 to 1. If y is equal to suppose 0.1 here, y 0.1 है तो x is what? X, the values possible for x is, okay, 0 to 0.9 like that. y 0.5 है तो x also 0 to 0.5. So y 0.9 है तो suppose x, the range of values possible for x is 0 to 0.1, like that. Okay, now and this line equation is of course x plus y is equals to 1, x plus y is equals to 1. So what are the range of, when you're fixing the y value को fix करने पर, y value fix करने पर, what are the corresponding range of values we expect for x? That depends on definitely y here. What are the range of here, the range of x values is here, the range of x values allowed is this, the range of x values allowed this, the range of x values allowed is this. What are the range of values allowed for x? Depends on y only, depends on y. Okay, so what that I can say, so what are the range of values allowed for x is definitely starts from 0 only. So on this line x to 0 only, so 0 to I can say, what is this, at this line pe, at this line pe, if you see x value at this line पे, this is which line, this is x plus y is equals to 1. So on this line किसी भी point पे आप check कीजिए, x is equals to 1 minus 5, x is equals to 1 minus 5. So you can write like this, the probability of x plus y less than 1. So x to 0 to 1 minus 1 and y is equals to 0 to 1. This is fxy of x comma y. This is e power minus x plus y dx dy. So this and this both will give you the same. Saptarshi Ishita Sakshi is saying that is 0.264. Rishabh Yadav is saying is 8,3 is Hamming code. It is one question given in the test series. Rishabh Yadav, I given the video solutions for test series. No, do check that. In the regular classroom, I given only some combinations of n comma k will become Hamming code. 8,3 will not become Hamming code. Okay. Will not become Hamming. I given some combination. Only some combinations will become Hamming code. No? Like 3,1, 7,4, okay, 15, 11. I given only some combinations of n comma k will become Hamming code. Do check once. Do check the notes once. You will come to know. Yes, you can. Maybe I will. I'm doing here. This is. I will do here or like this you can do. So this is x is 0 to 1 minus y, okay, and y is equals to 0 to 1, e power minus x, e power minus y you can write dx dy. So first to do integration with respect to x, okay, and if you do integration with respect to x, substitute the limits, then the total equation you get in terms of y. Thereafter you can do integration with respect to y. Okay. If you do integration with respect to x here, okay, this is integration, y is equals to 0 to 1. This is e power minus y. When you are doing integration with respect to, I am doing integration with respect to x, then e power minus y, okay, you can see that is simply a constant only when you are doing integration with respect to x, that is e power minus y. And what is the, if you do integration with respect to x, this is minus e power minus x, this is. And what the limits? Yes, you need to substitute the limits. X equal 0 to 1 minus y, and this is dy. Okay, then do substitute the limits here. This is y is equals to 0 to 1. This is e power minus y. If you substitute the limits, minus e power, if you substitute the upper limit, x का प्लेस में 1 minus y you have to substitute, so this is y minus 1 होगा. This is, and minus of minus is plus only. This is minus of minus plus, e power 0 is 1. This is dy. So y is equals to 0 to 1. This is, so it is minus e power minus 1. This is and plus e power minus y dy. This is, and if you do integration with respect to y, this is minus e power minus 1 y. This constant, what is the integration of this with respect to y? That is y only. And what is the integration of this? Minus e power minus y. Yes, you have to substitute the limits 0 to 1. So y का प्लेस में 1 substitute करने पर this is minus e power minus 1. y का प्लेस में you have to substitute 1. This is minus, and if you substitute y का प्लेस में 0 substitute करने पर this is 0 only, minus e power 0 is 1. So this is 1 minus minus plus only. This is 1 minus 2 into e power minus 1. This is, so what is the value of this? Is it is numerical answer type question? Yes, no? Yeah. So try to check with Calci. What is the answer for this? 0.264. Yes. So this will be the answer. Most of you given correct answers. Good. This is the next question. Try to do this question. Everyone try this. Now if you see this question, yes, a random signal here with power spectral density, okay, Sx of f, yes, it is given as 10 delta of f upon 50 is given to LTI filter with frequency response. Okay, so here random process, you can understand this is xt is given to LTI filter, okay, and the transfer function of this LTI filter is given HF. Then we have to find the power of the random process at the output of the filter. We have to find out. Okay, what is the random process at the output of the filter? I am denoting with YT. Then we have to find the power of this YT. Yes, here the power spectral density of xt is given, that is Sx of f is given. Okay, and output power को find करना है. Yes, what is the procedure for this? If the input PST is given and you need to find the power of the output process, first find the power spectral density of output random process. How to get the power spectral density of output process? Sy of f is equals to Sx of f into mod hf square. I know? Yes. So once we got output PST, the area under PST will give you the power. Okay? Yes. So Sx of f. First, if you plot this Sx of f in signals and systems, I hope you come across like how to plot this delta function. This is actually triangular pulse. Okay, yeah, this is the triangular pulse. Delta means this is the triangular pulse. Yes, if you plot this, yes, Sx of f with respect to f, what you see in the denominator 50, no? So 50 means it is minus 50 to 50. This is triangle, this is. And what is the height here is? The height will be 10. Yes. Height is 10 here. It is the triangular pulse. And if you plot the transfer function of the given LTI filter, transfer function, so it is HF given, so try to give the graphical representation of this HF. Yes, if you see, suppose a rect of this is f by some f naught, I am giving this is a rect of f by f naught. It is a rectangular pulse. Then how to plot this is, yes, it is a rectangular pulse with respect to f, this is with respect to f, and what you see in the denominator is f naught, no? So this is minus f naught by 2 to f naught by 2, this is. So what you see in the denominator that specifies the width of the pulse, the width of the pulse is f naught, and what is the height will be, the height is going to be a, the height will be a, like this. Then if you see rect of f by 10, if you plot, I am trying to plot this rect f upon 10. So what it will be, this is with respect to f, denominator you can see 10 here now, so this is from minus 5 to 5, I can say total width should be 10, and what is the height will be 1. It is a rect f upon 10, and f minus 20 by 10, if you see rect of f minus 20 by 10, so this is so this is delayed by 10, delayed by 20, I am sorry, it is delayed by 20 units. Delayed means shifted to right, so it is shifted to right by 20 units. Shifted to right means addition, minus 5 plus 20 will be 15, and 5 plus 20, this is 25, this is. It is rect f minus 20 upon 10. Then if you plot vector of f plus 20 upon 10, f plus 20 if you plot, this is f plus 20 means it is advanced by 20, advanced means shifted to left, this is shifted to left. 5 minus 20 is minus 15, minus 5 minus 20 minus 25, this is, so this is, and this is vector of f plus 20 upon 10, this is, okay, yes. Then you need to add these two. Yes, if you add these two, then it just looks like a band pass filter only you can expect. Just by adding these two, so it will be 15 to 25, and this is minus 25 to minus 15. The height is of course 1 here, this is, but if you see, it is multiplied with 5 here, multiplied with 5. Then what is the height you can expect here is, this height is going to be 5, and what I plotted is HF with respect to F, okay, so it is 15 Hertz to 25 Hertz you can expect. So this is simply a band pass filter. Now what I am understanding is, this random process, this LTI filter here is a band pass filter only, then we need to find the power of the output process, we have to find out, yes. Then yeah, and if you see HF square, yeah, AHF hai, this is, and HF square करने पर, this is mod HF square we need. So mod HF square means it will be, yes, if you mod HF square, if you do this 25 you will get, no, this is 25. So I can write Sy of f is equals to, mod HF square is 25 of course, so 25 times to Sx of f, this is, but this is valid in the interval of, in which interval this is 15 to 25, this is minus 25 to minus 15, this is, I can write minus 25 less than or equals to f less than or equals to minus 15, and in the interval 15 to 25, 15 less than or equals to f less than or equals to 25, and 0 elsewhere. Mod HF square का value तो 25 है, so you have to multiply with 25, Sx of f with 25, but this is valid only in this interval. But other than this interval, HF तो 0 है, 0 multiplied with something that will be 0. Okay, then output power, we need to find the power of Yt. How to get the power of Yt? This is the total area under PST. Area under PST will give you the power. This is okay. Sy of f, total area under PST will give you the corresponding power. Yes, if you plot, this is, it is minus infinite to infinite. So if you plot this 25 Sx of f, Sy of f को plot करने पर, yes, if you multiply this Sx of f with 25 से आप multiply करने पर, 25 से if you multiply, the height will become 250 now, this is. The height will be 250 and minus 50 to 50, this is. but we need to find the area under this. Okay, it's not minus infinity infinity because it is giving non-zero values only in this range. So we have to find the area. This is in the interval minus 25 to minus 15. This is, and this is 15 to 25. So we need to find this area. This is this area. This is. So what I plotted here, this is, I can say this is what you see. This is, I can say SYF. SYF is 25 times to SXF, but only in this region, only in this region. So what I mentioned here, this is, I can say SYF, SYF. So this total area under PST will give you the power. So this area plus this area को हम find करना है. Okay, yes, here this area is going to be same only. So I can write here, this is 2 times 2, this is I can write, yeah, so this is, I'm writing 2 times 2, let me find this area, 15 to 25. Okay, what is this line equation? If you see this line equation, if you try to see in the interval, this is this line equation, let's try to get, and once you got this line equation, let's find the area under this in the interval 15 to 25. Okay, yes, what is this line equation? So y is equals to mx plus c. Okay, y is equals to, so y axis variable is of course sy of f only, that's fine, sy of f. Okay, and slope, what is the slope of this? Change in y axis upon change in x axis. So this is 250 upon 50, that is 5 now, but this is minus 5. Decreasing means negative slope you can expect. Okay, and x axis variable is f plus c. How to get the c value here? So at f is equal 0, sy of f is 250. Okay, at f is equals to 0, okay, sy of f, sy of f means this is y only, I mean to say, at f is equals to 0, the y will be equals to 250. Okay, so from this c you will come to know, f is equal to 0, y is 250, so c I can say will be 250. So what is this line equation you will get? This line equation is, so this is y is equals to, this is, so minus 5f plus 250. Yes, it is in the interval from 0 to 50, 0 less than or equals to f less than or equals to 50. Okay, yes, so we need to find the area under this. Okay, we need to find the area under this, only in this interval we need to find out 15 to 25. And what is this line equation? This is minus 5f plus 250 df. This is, so what is that you got? So it will be equals to, this is 2 times 2, just minus 5, integration of f is f square by 2 plus 250f. This is, what the limits will be? 15 to 25. Okay, and do substitute the limits, upper and lower limits को substitute कीजिए. So it will be equals to, this is 2 times 2 minus 5 by 2. So it is 25 square, upper limit substitute करने पर minus, lower limit is 15 square plus 250 times to upper limit f का placement 25 minus 10, 25 minus 15 will be 10. This is, so if you do this, it comes to be 3000, you will get 3000 watts. So is it is numerical answer type question or MCQ question? MCQ question. So this is option B is correct here. Okay. Yes. $3,000 will be the answer for this. Yes, if you see the next question. So here, yes, two random variables x and y have a correlation coefficient of 0.2. Correlation coefficient. The correlation coefficient of xy you can denote with the rho xy. This is correlation coefficient. X has a mean of 5 and variance of 9. Okay, so expectation of x, the mean is 5 and variance of x, I'm denoting with sigma x square, variance of x is 9. What about y? Y has the mean of 5, y has the mean of 7, expectation of y is 7, the variance is 4. Fine. Then given z is equal to x plus y, z is equals to x plus y, then we need to find expectation of y z, we need to find out expectation of y z. Can anyone try to give the answer for this? Yes, it will be equals to, yes, expectation of y into z, to it is x plus y now. So this is expectation of xy plus y square. You can write expectation of xy, you can apply expectation separately to each terms, you can write plus expectation of y square. This is expectation of yz. I'm taking this as some equation 1, so we need to find this. So if you see expectation of y square, the mean square value of y will be equals to, mean square value will give you the total power you can write dc power plus ac power, you can write expectation of y square, dc value को square करने पर you get dc power plus ac power. So this will be expectation of y whole square, 49 plus this is 4, this is 53. Expectation of y square to we got. Then you need to find expectation of xy. Okay, expectation of xy. How to get this? The correlation coefficient is given up, from that we can try. Yes, the correlation coefficient of xy will be equals to, this is covariance of xy upon sigma x into sigma y. This is how you will find the correlation coefficient between two random variables. Okay, and yes, this is given how much, 0.2 is given, this is given point 2 no? And the covariance of xy upon sigma x. Sigma x is 3, sigma x square is 9, sigma x is 3, sigma y is 2. So this is covariance between these two random variables will be equals to, this is 6 times 2.2, that will be 1.2. This is covariance, though you can write as expectation of xy minus expectation of x into expectation of y is 1.2. So from this you can get expectation of xy now, you can get from that. Yes, this will be, so expectation of xy is what we need, is equals to 1.2 plus expectation of x into expectation of y. What is expectation of x into expectation of y? That is 5 times 2, 7, that is 35. So this is 36.2 I can say. So from equation 1 say, so expectation of yz will be equals to, so expectation of xy, that is 36.2 plus expectation of y square, how much we got? 53. So how much it will be? It is 89.2. 89.2. So round off to one decimal place, that is 89.2 only will be the answer. Yes, Saptarshi Bishwas and Sakshi Agarwal and Barik, correct answers. Yes. And if you see this question, this is about frequency modulation. Yes, MSA signal is given here, 2 cos 2 pi into 10 power 3t. It frequency modulates a 1 megahertz carrier. So carrier frequency is given, and to produce a peak frequency deviation of 4 kilohertz. Peak frequency deviation means maximum frequency deviation only, that is delta f. Then the time domain representation of the resultant FM signal. I am expecting everyone should answer this. Can you try that, everyone? It's easy. What is the answer? Try. Okay, yes. The message signal is a sinusoidal message signal. Then what is the FM ka message signal? Sinusoidal message signal means it is single tone FM only. What is a single tone FM expression? Carrier signal cos only, the default we take, because in all the options also you can see the carrier signal is cosine signal only, no discrepancy in the options. So I am taking this is cos only. If the carrier signal sine दिया है तो question में, okay, then here also you get cos. If sine is given as carrier, then in the FM expression also you get sine here. Okay, AC cos 2 pi FCT plus beta. Tell me, is it is beta sine 2 pi FMT or cos 2 pi FMT? Here message signal cos है ना, message signal cos है तो in the single tone FM expression we get sine only, beta sine 2 pi FMT. Because if you recall the general expression of FM signal, what is the general expression of FM signal? AC cos 2 pi FCT plus 2 pi KF integration MTDT. Integration MTDT. So MT to cos है, integration of cos you will get sine here. So you will get sine here. If the message signal sine है तो, if the message signal sine है तो we get cos here. Okay, you will get cos here. ठीक है. Then beta. Beta तो delta F by FM. Delta F is 4 kilohertz. Message frequency. If you compare message signal with AM cos 2 pi FMT, FM is 10 power 3 hertz or 1 kilohertz I can say. So beta will be 4. So this will be FM ka expression. AC, the carrier amplitude is not given, so I am just keeping as AC cos 2 pi FC 1 megahertz, or I can say 10 power 6 T plus beta is 4 sine 2 pi FM. Message frequency is 10 power 3 compared with cos 2 pi FMT. So this is 10 power 3 T. This is beta sine 2 pi FMT. Which option is matching here? Option C is matching. Option C will be correct. Yes, good. Sakshi, Aryan, Obita, Ishita, Saptarshi, Barik. Correct answer. If you see the next question. So this is about super heterodyne receivers. Yes. So what is this question here is, the intermediate frequency of AM super heterodyne receiver is 450 kilohertz. Intermediate frequency means it is IF, I am denoting it IF. The local oscillator frequency of the mixer is selected such that FL greater than FC. Okay, FC is the carrier frequency of the selected station. You can denote with Fs also. Okay, FL greater than Fs. The receiver is tuned to the station whose carrier frequency is 600 kHz. The carrier frequency of the tuned station or selected station we denote with Fs. Okay. The loaded quality factor of the RF amplifier is 50. The quality factor Q is given. Then the image rejection ratio of the receiver will be equals to IRR, we have to find out. The IRR alpha is equals to root over 1 plus P square Q square. Hai na? Yes. Okay. Quality factor Q is given 50 of course. Then we have to find the parameter P. P is equals to what? FSI by Fs minus Fs by Fsi. Okay. Now FSI, since FL greater than FS, it is given in the question, FL greater than FC means, okay, FL greater than FS, you can understand. The local oscillator frequency, of course, greater than the carrier frequency of the selected station. Then IF will be equals to FL minus FS. And mixer, of course, if FL greater than FS hai, to the image frequency FSI I can write FS plus 2IF I can write. If FL less than FS hai, to if FL less than FS, then image frequency will be FS minus 2IF hoga. But here this is FS plus 2IF. So FSI is equals to, FS is how much? 600 kilohertz. Okay, 2IF means this is 900K. So this is 1500 kilohertz. Then what is the P value is? FSI upon FS. Kilohertz will be cancelled, minus FS upon FSI. This is, so what is that P value you will get? Anyone got the answer? Yes, this will be 2.1. P is equals to, then IRR alpha equals to root over 1 plus P square into quality factor given 50, no? This is 50 square, and this will be equals to this will be equals to 105.00. Yes, this is 105 only. Yes, Arsh and Sakshi correct answers. The Chinmay correct answer. If you see the next question, yes. Try this question. A binary source x is equals to x0, x1 is connected to the channel shown in the figure below. Yes. Okay, here the channel diagram is given. If the source emits the symbol, the transmitted symbols here x0 and x1, the received symbols denoted with y0, ye and y1. Okay, denoted like that, received symbols. The source emits the symbol x0 with probability 0.4. So Px0 is 0.4, then what will be Px1 is equals to 0.6. Is equals to 0.6. Total probability should be 1, so it is 0.6. Then the entropy of the output of the channel will be dash bits per symbol. So what is the entropy of the output? So I am denoting with Hy. To find the entropy, we need the corresponding probabilities. So this is Pyi log Pyi. This is base will be 2. because the units expected in bits per symbol, then this is base 2. If the units expected here, if at all nats per symbol, then base E. Decits per symbol, then if it is given decits per symbol, the base will be 10, like that. Okay. Now we need this probabilities py0, pye and py1 we have to find out. So one way to get this is you can get py matrix, because py0, pye, py1, these are the elements of py matrix. So py, how to get py? This is px into py by x. This is, so px elements so given, and from this channel diagram you can get py by x you will get. Okay, then you can get py matrix. Even if you see px is a row matrix. So what that sorts probabilities 0.4 and 0.6. And if you see py by x, map the elements like this: x0, x1, y0, ye, y1. This is map x and y elements. What is the probability of transmitted x0 received as y0? 0.6. x0 received as ye, 0.4, and this is 0. Next, x1 received as y0, 0, ye 0, x1 received as y1 is 1. Then py matrix will be px 0.4, 0.6 into py by x. Py by x is 0.6, 0.4, 0, 0, 0, 1. So if you do this matrix multiplication, multiply these row elements with the column elements. 0.24, 0.4 into 0.6, 0.24. Next 0.16 and 0.6. These are the py elements. So I can say py0 is 0.24. Next, pye is 0.16. py1 is 0.6. You can get this receiver ka probabilities, you can get in other way also. You can get, what is the other way is, like if you see py0, to receive y0 at the output, the only possibility is x0 should be generated and transmitted x0 should be received as y0, because there is no chance of x1 received as y0. Okay, the only possibility to receive y0 is x0 should be generated. What is the probability for x0 should be generated? 0.4, and the transmitted x0 should be received as y0. So for transmitted x0 to be received as y0, what is the probability? 0.6. So this is 0.24, like that. And ye के लिए, to receive ye, okay, the only possibility is x0 should be generated, transmitted x0 should be received as ye, because there is no chance of x1 received as ye. So x0 should be generated. What is the probability for x0 should be generated? 0.4. x0 received as ye, 0.4. So 0.16, simply you can get like this. py1, the only chance for y1 is x1 should be generated, transmitted x1 should be received as y1. x1 generate होने के लिए क्या probability है? That 0.6, and that is received as y1, 1. This is 0.6. You can get like this also. Then hy. Then what is the entropy of the receiver? It is minus, yes, this is 0.24 log 0.24 base 2 plus 0.16 log 0.16 base 2 plus 0.6 log 0.6 base 2. This is so if you do this calculation, what is the entropy you are getting here? Hy will be how much? Yes, this is 1.356 you will get bits per symbol. If you round off to 2 decimal places, if it is mentioned nahi hai question, but if it is mentioned, then 1.36 you can write, round off to 2 decimal places. But even if you keep the answer 1.35 or 1.356 or 1.36, so you will get the marks for that. Okay, no need to worry about that. If you see the next question, try this question. Yes. Aryan, you are saying, sir, channel capacity. What is channel capacity? That becomes a different question. Aryan, just post the same question in the Telegram to me. I will try to discuss that. I will give the answer for that. Okay? Yeah. But in this given allotted time, let me discuss the questions which I want to convey to you first. Okay? Yes. Here, a random process xt is given like this: a cos 2 pi f ct. Fine. Here A is the Gaussian distributed random variable of 0 mean and variance sigma square. Okay, expectation of A is given how much? Okay, Gaussian random variable this is with 0 mean. Mean 0. Variance is sigma A square denoted with. This random process is applied to an ideal integrator where yt is equals to this. The relation between xt and yt is given. Okay, then the mean and variance of yt will be, we have to find out. Yes, if you see, yt is equals to, it is integration 0 to t, this is x tau d tau, this is. Okay. The mean and variance of yt. Anyone got the answer? Yes, if you see, if you find the integration here, 0 to t x tau a cos 2 pi f c tau d tau. Your integration with respect to tau, okay, then a you can let outside. Integration of cos will be sine 2 pi f c tau upon, what is the differentiation of this argument with respect to tau? That is 2 pi f c. Of course, you need to substitute the limits 0 to t. Okay, if you substitute the upper limit, tau ka place mein if you substitute upper limit, this is a upon 2 pi f c sine 2 pi f c t, and if you substitute the lower limit, sine 0 to 0 only. So this is actually yt indirectly. Okay, now we need to find the mean and variance of yt. What is the expectation of yt? Here a is the only random variable here, except a, everything else will be deterministic signal only, deterministic quantity only. Yes, I am finding the mean at a specific time instant. We find the mean at a specific time instant. Okay, at the given time instant means for the given t value, at the given time instant, at the given t value you get, okay, the value of sine 2 pi f c t तो हम determine कर सकते हैं at the given t के लिए, for the given t what is sine 2 pi f c t का value को we can determine it. So it is a deterministic quantity, I can say. In sine 2 pi f c t nothing random here, इधर कुछ random नहीं है, it is, I can say, deterministic quantity only. Expectation of deterministic quantity will be same deterministic. Okay, like this, simply I can see this is some k, I can see as at the given t, at the we find the mean at a specific time instant. For the, at the given time instant, the sine 2 pi f c t will give you some value, some k, something like that. Like if you see expectation of kx, you can write k expectation of x, you can write. So this is sine 2 pi f c t, sine 2 pi f c t upon 2 pi f c into expectation of a. Expectation of a to given 0, so 0 times to something that will be 0 only. It is a mean. Then what about variance? Variance of yt will be equals to, okay, yes, we are finding this variance at a specific time instant. Okay, this mean means this is ensemble mean only, you can understand the default of ensemble mean only, you can understand, and we find the ensemble averages at a specific time instant. We are finding the variance at a specific time instant. Okay, and at the given time instant pay, this is at the given time instant, the sine 2 pi f c t will give you some specific value at the given t value. Okay, you get some value for it, you will get some value, some k. Okay, now if you see, this is where a is the only random variable. You know this, now variance of some kx, where k is the random variable and k is some deterministic quantity, then that is k square variance of x, k square variance of x. Okay, then expectation of yt will be, this is, it is just, for me this is just some k here. At the given t, we find the variance at a specific time instant. Whose time instant पे the sine 2 pi f c t upon 2 pi f c will give you some value, some k. Just I am seeing this as k times to some x here, where x is the random variable, here a is the random variable. So variance of kx is k square variance of x. K square means what here? This is sine square 2 pi f c t upon 2 pi f c square into variance of a. Variance of a क्या दिया है क्वेश्चन में, सिग्मा a स्क्वायर ना, so this is sine square 2 pi fct upon 2 pi fc square into sigma a square. Any option is matching with this? Yes, option A is matching with this. Yes. Option A. I expect an answer from you. Yeah, Saptarshi Bishwas, that is A. Yeah, that's correct. If you see this question, try this question. Yes, if you see this question, a white noise process xt with 0 mean and pst n naught by 2. Okay, so for xt के लिए okay, mean is given 0 and power spectral density is n naught by 2 is applied to LTI filter of impulse response ht. So this random process xt is given to LTI filter. This is LTI filter having the impulse response ht and producing the output yt. Okay, the cross correlation function ryx tau is ryx tau. What is ryx tau formula क्या है? The regular classroom are given this formula. So I given the formula ryx tau is rx tau convolution with h minus tau, है ना? rxy tau, what is the formula I given? rxy tau is rx tau convolution with h tau. This is the formula I given, rxy tau. ryx tau is rxy of minus tau. This is, है ना? ryx tau is rxy of minus tau. So if you see rxy of minus tau, rx of minus tau is rx tau only, and it is h of minus tau you will get. Okay, how to get rx tau? The power spectral density of xt is given, sxf is n naught by 2 is given. Then what is rx tau? PST of xt is given. Then how to get its ACF? The inverse Fourier transformation of PST. The inverse Fourier transformation of PST will give you ACF. So this is inverse Fourier transformation of, this is n naught by 2. N naught by 2 is constant only, you can write outside. And what is the inverse Fourier transformation of 1 del t? No, del t. Okay, but I need in tau axis, with reference to tau axis I need, so n naught by 2 del tau. So the autocorrelation function of white noise will be n naught by 2 del tau. Then r yx tau is equals to rx tau is n naught by 2 del tau convolution with h of minus tau. This is, if you do convolution of impulse function with any other function, impulse function, if you see with any other function, you will get the same function only. xt convolve with del t will be xt only. So if you see this is some xt convolve with del t, the same xt this is. So I can say this is n naught by 2, this is n naught by 2, this is h of minus tau, I can say this is. It is, if you see xt convolve with del t will be same xt, so h of minus tau. So what is the answer here is C will be the answer for it. Yes, Sahu and Chinmay Srivatsava correct answers. Good. If you see this question, this is so here the power spectral density of a random process xt is given. The power spectral density of xt is given below. The sampling rates which gives uncorrelated samples of xt is /r. This is okay. So in the question, whenever you see the framing like this E/R, then you can see this as MSQ type question only. It is multiple select type question. So here one or more options can be correct. One or more options can be correct. So here the power spectral density of xt is given. Then the sampling rates which gives uncorrelated samples of xt. Uncorrelated samples of xt we have to find out. Okay. Now, so if you see the random process xt, some random process xt is given like this. It is random signal, you can understand. The same model of question we done, okay, in the regular classroom. Xt with respect to t, okay, and the power spectral density of this random process is given here, Sx of f versus f. So suppose if this xt is sampling here, like it is getting it is sampling here, this is sampling, okay, and is asking this samples what you will get here. The samples what you are getting will be uncorrelated for which sampling rates? किस sampling rates के लिए this samples will be uncorrelated. So this sampling interval I am denoting with TS here. Sampling interval is TS, and Fs will be equals what? 1 upon Ts. Okay. Then the question is for which sampling rates के लिए? For which sampling rates के लिए the samples what you are getting will be uncorrelated. We have to find out. So the samples what we are getting here, okay, whether these samples, the sample points, okay, this you can see this is sample points only. So to check whether the sample points are uncorrelated or not, correlated or uncorrelated, the ACF, the autocorrelation function will better help us for that. ACF will better help us for that. If you see autocorrelation function of xt, so this is ACF of xt. If you see, this is Rx tau. What is the inverse Fourier transformation of this? What is the inverse Fourier transformation of triangle? Will be sink square function of sink square. Yes, it is simply, what is the area under this? Area will be, it is yes, area will be half times to base. Base is what? 2f0. 2f0. Height is what? 1. So this will be 2 to cancel f0. So area you have to write, and sink square, and this is from minus f0 to f0 now. So f0 and tau, this is f0 tau, sink square f0 tau. Yes, I hope you know this. Like if you see a tau, this is sink square f tau, height tau, this is A tau sinc square f tau. What is the inverse Fourier transformation of this? The inverse Fourier transformation of this will be, this is, yes, triangle. So this is minus tau to tau, this is with respect to t, this inverse Fourier transformation of this. The height will be A. Okay, yes. This will be A tau sinc square f tau. This is the inverse Fourier transformation. What is the area under this? Area under this is A tau. Okay, and this is f tau now. So f tau means that is from minus tau to tau you will get, minus tau to tau you will get. So simply what is the area under this? Area under this, that is f naught sinc square, and this is, if you see minus tau to tau means tau is what here, f naught. So f naught here. Okay. Here I written inverse Fourier transformation of sinc square function. If you see inverse Fourier transform from duality property, if you write inverse Fourier transformation of triangle, if you write, so this will be, it will be like this. Triangle के लिए this is, if you see, yeah, just here f का place में t you can write and t का place में f. Duality property it will works. T का place में f and f का place में t. ठीक है. The inverse Fourier transformation of this will be like this. Okay, Rx tau. So if you plot this Rx tau को आप plot करने पर, this is, so this is Rx tau with respect to tau. Sinc function will be like this. Actually sinc function will be like this. Is going to be like this, sinc function. Okay, if you square it, negative also becomes positive, no? Negative becomes positive. So this is like this. So this is going to be like this. This is, and this is becoming 0 for which tau values here you can see. It is becoming 0 for which tau values. Yes, if you see sinc f naught tau, because sinc x will become 0. Sinc x, if you take, will become 0 when x is plus minus 1 plus minus 2. So this is when f naught tau is plus minus 1 plus minus 2 plus minus 3, this sinc function will become 0. So किस tau values के लिए this is becoming 0? I plotted with respect to tau. So when tau is plus minus 1 by f naught, plus minus 1 by f naught. So it is 1 by f naught minus 1 by f naught and plus minus 2 by f naught. So this is 2 by f naught minus 2 by f naught. Next 3 by f naught minus 3 by f naught. So here Rx tau is becoming 0 when tau is equals to, I can write plus minus 1 by f naught plus minus 2 by f naught plus minus 3 by f naught and dash dash dash. This is becoming 0. A tau here, in plotting Rx tau with respect to tau, tau specifies the time difference only, you have to understand. Time difference means we are estimating. Okay, what I am trying to find from this ACF here is I am trying to estimate the correlation of this random process xt with the time difference of tau. Okay, with this Rx tau with respect to tau I plotted now. So with this plot of Rx tau, what I am trying to estimate is I am trying to estimate the correlation between the sample points, correlation between the sample points with the time difference of tau. So here time difference, here Ts is nothing but tau only. Okay. So with the time difference of tau, what is the correlation? What is the similarity between corresponding sample points with the time difference of tau? That is what I am trying to estimate here. Okay. So here with reference to the given question, this tau you can see as Ts only, the time gap between samples. Okay, time gap between samples, that is Ts only, sampling interval, and with reference to ACF discussion, this time difference is nothing but tau only, will be tau. So if R of tau 0 hai to, R of tau 0 means I can say there is no correlation between the sample points. ACF will give you the degree of correlation between sample points. We can estimate from Rx tau. Rx tau 0 means what? There is no correlation. Okay, if you take tau is 1 upon f naught, Rx tau we got 0. Okay, so when we are talking about time difference, don't give any importance to this negative sign. Iska koi importance nahi hai. So this is just time difference only. You are looking from right to left, yeah, left to right. That only the difference specified by this sign difference. Okay, don't give any importance to negative sign. So with tau is 1 by f naught, means with the time difference of 1 by f naught, R of tau you are getting 0. R of tau 0 means what? There is no correlation between the sample points, and those sample points are said to be uncorrelated. R of tau 0 means uncorrelated. Even with the time difference of 2 by f naught, with the time difference 2 by f naught also, the corresponding sample points are uncorrelated. So R of tau 0 means I can say the corresponding sample points are uncorrelated. So with the time difference of 1 by f naught, 2 by f naught, 3 by f naught, the corresponding sample points will be uncorrelated. Okay. For other tau values, like if you take tau value, suppose 1 upon 2 f naught, something like that, then R of tau not becoming 0. R of tau not becoming 0 means some correlation is there between sample points, then that sample points are said to be correlated. R of tau 0 hai to uncorrelated. So I can say this sample points looks to be uncorrelated with Ts is equals to a time difference tau here. The time difference tau you can see a sampling interval only Ts. So when Ts equals to 1 by f naught, I can say this is, and 2 by f naught, 3 by f naught, and 4 by f naught. Okay, then the corresponding sample points are, I can say, uncorrelated. Sample points are uncorrelated. And what is the corresponding sampling rate? If Ts is 1 upon f naught, okay, if you sample this, if you sample this, yes, it's something like this, sampling. If you sample this with the sampling interval 1 upon f naught with the time difference of 1 upon f naught, the corresponding sample points are uncorrelated. Or even if you sample this with sampling interval 2 upon f naught, those sample points also uncorrelated. Those sample points also uncorrelated like this. Then what will be the corresponding sampling rates here? Ts, Fs is 1 upon Ts, no? 1 upon Ts. So I can say when Fs with the sampling rate of Fs is equals to f naught, this is, and f naught by 2. F naught by 2 means what? This is f naught by 2, f naught by 3, f naught by 4. So for these respective sampling rates के लिए, the corresponding sample points are uncorrelated, I can say. With this, if you do sampling of random process with the sampling rate of f naught here, 0.5 f naught, okay, 0.33 f naught, 0.25 f naught, the corresponding sample points will be uncorrelated. Then which option is going to be correct? F naught, 0.5 f naught, 0.33 f naught, 0.25 f naught. Okay, yes. So f naught, you can see, yes, 0.5 f naught. So B and D are incorrect. So A and C are going to be correct, like this. Good question. If you see the next question, Try this question. Okay, and everyone, I think for the previous question you given the answers for TS के लिए, I think. Okay, for which tau values? Okay, you given the answer which tau values, I think, no? Then also that is not correct, no? 2f0, 4f0, how that will be correct? Okay, some mistake in conversion, I think. Yeah. Try this question. Yes, if you see this question here, a random telegraph signal xt having ACF, the autocorrelation function of a random signal is given e power minus 2a mod tau, where a is the constant, is applied to low pass RC filter. Okay? The output PST SYF at f is equal 0 will be. Okay, yes, same here. Here this xt is given to, okay, low pass RC filter. Okay, RC LPF, low pass RC filter, RC low pass filter. Then output random process I am taking YT. Okay, the ACF of xt is given, Rx tau is e power minus 2a mod tau. This is okay. Then this question is all about the PST of the output. Output PST, okay, at f is equal 0 we have to find out. At f is equal 0 will be. So output PST is equals to, you can write input PSD into mod HF square, and input PST into mod HF square. The transfer function of this RC low pass filter I am denoting with HF. So if you take RC low pass filter, this is R and C. This is. So what is the transfer function of RC low pass filter? HF is equals to, this is from voltage division rule, 1 upon j omega c divided with R plus 1 upon j omega c. Okay, so it is 1 by 1 plus j omega. Omega means 2 pi f RC. This is, it is HF. Okay, then what is mod HF will be? So mod HF will be, this is 1 upon root over 1 plus 2 pi f RC square. This is okay. This is mod HF. Okay. Then we need to find the PST of the input. We need Sx of f. ACF of xt is given. Then how to get PST? How to get PST is the Fourier transformation. The Fourier transformation of Rx tau will give you PST. What is the Fourier transformation of this? If you see e power minus a mod tau, what is the Fourier transformation of this? 2a upon a square plus omega square. Omega is 2 pi f. Okay, this is. Now here a का place में 2a है. If you compare with this, a का place में 2a है. So this is 2 into a का place में 2a. This is upon 2a square plus this is 4 pi square f square. This is. Then you can write output PST is equals to input PST. What is the input PST? It is, if you take 4 common, so this is a, you will get here a upon 4 will be cancelled, numerator 4, denominator also 4, so it is 4a square. 4 if you take common, this is a square, that will be plus, yes, this is pi f square, this is pi f square into, yes, syf is sx of f. If you take this as equation 1, so from equation 1 I am writing this is mod hf square. If you square it, this is 1 upon 1 plus 2 pi f rc square. Okay. Now at f is equal 0, if you see at f is equal 0, what is syf will be? At f is equal 0, this is f का प्लेस में 0 सब्स्टिट्यूट करने पर दिस इज a अपॉन दिस इज a स्क्वायर इंटू f का प्लेस में 0 है, f का प्लेस में 0, this is 1 only. At f is equal 0, at f is equal 0, this is 1 only, it is 1, a upon a square, this is a upon a square, so it is 1 by a, I can say, or a inverse. Which option is correct? Option C will be correct. Yes. Yes, 1 upon a, that's good answer. Barak, Saptarshi, Ishita, Sahu are correct answers. Good. If you say this question, can you try that? Yes, if you see this question, a white Gaussian noise process of 0 mean, okay, and PST N0 by 2 is applied to high pass RL filter shown below. Okay, so I'm taking the input is some xt, I'm denoting with the output is, suppose I'm denoting with yt. xt का mean क्या दिया है 0, I'm denoting with mx, the mean will be 0. And PST, the PST of xt, Sx of f is N0 by 2. Then we need to find the variance of output. The variance of yt we have to find out. Okay. Yes, this is how to find the variance of yt. Okay, variance of yt. देखो, how I can find is the variance of yt. Input PST is given ना, ठीक है. The variance is equals to sigma square m2 minus m1 square na? So this is expectation of y square t minus expectation of yt whole square. Mean square value minus square of mean will give you the variance. Expectation of yt. Input mean 0 है तो, okay, it is LTI filter of course. Okay, if you pass a random process through some LTI filter, then output mean you can write as, if input mean constant है तो, if input mean constant, then output mean is input mean into h of 0. Input mean mx तो 0 है, mx 0 है तो my also 0. My means it is expectation of output only, expectation of yt. Means if input mean 0 hai to straight away you can write output mean also 0 you can write. Okay, expectation of yt 0. Then variance of yt, this is variance of yt is equals to expectation of y square t. Expectation of y square t you can write as expectation of yt into yt, that is ry0 only. ACF at the origin will give you the mean square value. ACF at the origin will give you the power, will give you the mean square value. So expectation of y square t, expectation of yt into yt. Yt into yt means time difference is 0, so that is ry0. So first let's find ry ACF of output ry tau. Let's find that first. So input PST is given. First you can find output PST. Once you got output PST, the inverse Fourier transformation of PST will give you ACF. है ना? So output PSD is input PSD into, this is mod HF square. Mod HF square, and HF if you see from voltage division rule, this is what is the inductive reactance J omega L. This is omega ka place mein you can write 2 pi f, you can write if you want to write in F domain, fine, upon R plus J omega L. And what is mod JF, mod HF will be equals to, okay, modulus of the numerator is, this is omega L upon, this is root over R square plus omega L square, this is, okay. Then output PST is equals to SYF is equals to SXF, though it is N0 by 2 only into mod HF square. If you square it, that is omega L square upon, it is r square plus omega L square. This is Sy of f, that is. And we have to find the inverse Fourier transformation for that. To find the inverse Fourier transformation, I can write in much convenient form. We can write. So if you write in convenient form, if you write, so let me write this is n0 by 2. Yes, this is. So if you write this is r square, if you take common, this is omega L by r square. If you take common omega L by r square, you can write numerator this is upon 1 plus this is omega L by r square. This is, I am taking r square common. If you take r square common, if you write r square to the numerator, omega L by r square hoga. This is like this. So to write inverse Fourier transformation to this, let me write in much convenient form. I am going to write yes. So it will be, if you write 1 plus, okay, in the numerator add 1 and subtract 1, then so 1 plus omega L, if you add 1 here, this is, I am adding 1 and subtracting 1, this is 1 plus and minus 1. So 1 plus omega L r square upon this, cancel, that will be 1 only. This is minus 1 upon 1 plus omega L by r square. This is, you can write. Then what is the inverse Fourier transformation of this? Will be ry tau. So ry tau is equals to n0 by 2, you can write outside. 1 ka inverse Fourier transformation del tau. This is minus. So it is looks to be, we know this e power minus a mod tau. This is 2a by a square plus omega square. This will be. Okay. Now, even if you take 2a by a square plus omega square, or you can write like this also. So if you take a square, if you take common here, a square if you take common, this is 2 by a times 2. A square if you take common, a will be cancelled, 1 plus omega by a square, you can write. This is e power minus a mod tau. And if you write to left side, this is a by 2 into e power minus a mod tau. This is, what is the Fourier transformation to this? If you make it to left side, this is a by 2 hoga, 1 plus omega upon a square. So इधर a का place में क्या है इधर? Just 1 upon a is equals to, comparison से 1 by a is equals to L by R. This is okay, and a will be equals to R upon L. This is a is equals R upon L. Then A का प्लेस में R अपॉन L लिखना है. दिस इज R अपॉन L, R by 2L e पावर. A का प्लेस में क्या है? R by L. This is mod tau. This is. It is the ACF we got. है ना? Yes. Now the question here is we need to find Ry of 0. We need to find out the variance of yt is equals to Ry0. है ना? This is variance of yt will be Ry0. So what is Ry tau at tau is equal 0? At tau is equal 0, it is impulse function. What is the value of impulse function at the origin? Del tau at tau is equal 0. Impulse function at the origin will be infinite. The value of the impulse function, the value, it's not area. Area to 1 hai, but I am asking the value here. R of tau at tau is equal 0. What is del of tau at tau is equal 0? At tau is equal 0. What is del of tau ka value? Infinite. Okay. From infinite you are subtracting something. Okay. You are subtracting some value. So infinite say, even if you subtract some value, this resultant what you are getting, this is infinitely large, I can say. Okay, it is infinitely large, almost infinite, I can say. So this is equals to infinitely large. Infinitely large. So option B is going to be correct. है ना? Yes. Infinite. Good. Saptarshi and Shreyas Srivatsava. Good answers. Yes. If you see this question, two random variables x and y are defined like this. X is cos theta, y is sin theta, where theta is a random variable uniformly distributed. Yeah, theta is the random variable. Theta random variable hai to x also going to be random variable only. Theta can be any value between 0 and 2 pi. Theta can be any value between 0 and 2 pi. Then okay, so x also can be any value x, but in some specific range x can be any value. X can be any value. So what is x value means? That is undeterministic. X value undeterministic means x is undeterministic variable or random variable, I can say. So x and y are random variables. Then which of the following is/are correct? So I said already, if you see the phrase like this is/are, you can understand this is MSQ type question, multiple select type question. This is one or more options can be correct here. Can you, let's see. If you see expectation of xy and expectation of x into expectation of y, the first one, the validity of the first one, let's check. Yeah, let's check the validity of the first one, option A. So if you see expectation of x, that is expectation of cos theta, expectation of cos theta. Okay, what is the random variable involved here? Theta is the random variable involved, and is continuous random variable or discrete random variable? It is continuous random variable. If you see the density function of theta, f of theta, this is with respect to theta, it is uniformly distributed in the interval 0 to 2 pi. This is, the height is 1 upon 2 pi, of course. Okay, yes. So theta is the random variable involved is theta. Theta is a continuous random variable. Okay, so integration, for which quantity we are finding expectation same quantity multiplied with the density function. What is the random variable here? Theta. So f of theta d theta. The range of values possible for theta 0 to 2 pi. This is, yes, f of theta का value कितना है? 1 upon 2 pi. You can write outside. Okay, what is the integration of cos theta? F of theta to 1 upon 2 pi. Integration of cos theta will be sin theta only. The limits will be 0 to 2 pi. Okay, so if you substitute the limits here, this is sin 2 pi minus sin 0. Sin 2 pi is 0, sin 0 also 0, so this is 0. So expectation of x, I can say mx will be 0. Can you find expectation of y? Ishita is saying A, C, D will be correct. And Sahu is saying A, B, D will be correct. Okay. And if you see expectation of y, see this? Expectation of y will be, expectation of y is what? Sin theta. Same thing. Okay, integration, for which quantity you are finding expectation same quantity multiplied with the density function. The random variable is theta, f of theta d theta. This is the range of values possible for theta is 0 to 2 pi. This is, so this will be, f of theta is 1 upon 2 pi. Integration of cos theta is minus sin theta. So limits will be 0 to 2 pi. And if you substitute the limits here, this is 1 upon 2 pi. If you substitute the upper limit, minus cos 2 pi, minus minus will be plus. So this is cos 0. Cos 2 pi is 1, cos 0 is also 1, 1 minus 1 will be 0. So expectation of yt, my also 0, I can say. Mx 0, my will be 0. And if you find out expectation of xy, so let me do here. I will do here. Expectation of xy. So expectation of this is cos theta sin theta. What is the random variable involved here? Theta. So this is integration, and the theta is a continuous random variable. For which quantity we are finding expectation? Same quantity you have to write. Same quantity multiplied with the density function. What is the random variable is theta? So f of theta d theta, where theta is 0 to 2 pi. Range of values possible for theta. Okay. So f of theta to 1 upon 2 pi you can write. And cos theta, this is sin theta, you can write as sin 2 theta upon 2. You can write like that. Sin 2 theta is 2 sin theta cos theta, no? This is d theta, and this is 1 upon 4 pi, this is 2, you can write outside, integration of sin 2 theta, this is cos 2 theta upon 2, this is 0 to 2 pi. Okay, and if you substitute the limits, okay, it is cos 4 pi upon cos 4 pi, upper limit if you substitute minus cos 0, cos 4 pi is 1, cos 0 is also 1, so it is 0. So expectation of xy is 0. Now you can see expectation of xy is 0 and expectation of x into expectation of y also 0. You know, it is 0 0 0. So option A looks to be correct. And what about option B? And even I can write the covariance also here itself. I can write option D though. If you, by having this data, you can write covariance. If you see covariance of xy, covariance of xy is what? Expectation of xy minus x in minus expectation of x into expectation of y. Covariance of xy, expectation of xy minus expectation of x into expectation of y. So it is 0 minus 0. Covariance is 0. Covariance 0 means even I can say like this. Covariance will give you the measure of correlation between two random variables. Measure of correlation between two random variables. This is covariance is 0 means there is no correlation between x and y. Even I can say x and y are uncorrelated, I can say. Covariance 0 hai to those two random variables are said to be uncorrelated. Something extra I given here. Now what about this is also 0, you know, covariance to 0. Let's check the validity of this B and B and C. Okay, so if you see first expectation of x square, if you try to find out. So expectation of x square means what? This is cos squared theta, and this is, yeah. What is the? It is integration for which quantity you are finding expectation, same quantity multiplied with the density function of the random variable f of theta d theta, and this is 0 to 2 pi. It is 1 upon 2 pi. F of theta is cos squared theta, so you can write 1 plus cos 2 theta by 2 d theta. So it is 1 upon 4 pi, you can write. Okay, 2 you can write outside. 1 ka integration to theta plus cos 2 theta. Cos ka integration to this is sine only. Cos ka integration will be sine. Integration of sine is minus cos, no? This is actually minus cos. Even it is minus cos, okay. If you substitute upper and lower limits, that will be 0 only. Okay. So integration of cos will be sine. This is sine 2 theta upon, what is the differentiation of this argument with respect to theta? 2. This is, and what the limits will be? 0 to 2 pi. This is, and if you substitute upper limit, this is theta ka place mein 2 pi, this is plus, and sine 4 pi, sine 4 pi to 0 only, this is minus. So if you substitute lower limit, 0 substitute karne par 0 0, altogether this is 0 only. This is, so it is simply 2 pi upon 4 pi, this is 1 by 2. Expectation of x square is 1 by 2. this is. Similarly, you can try for expectation of y square. Okay, expectation of y square also you can try. You will get the same 1 by 2 you will get. You can try later, this is. Okay, then if you see expectation of x square y square, this is. Expectation of x square y square. So this is expectation of, this is cos square theta sin square theta. So it is for which quantity we are finding expectation, same quantity I am writing, cos square theta sin square theta multiplied with f of theta d theta, and this is 0 to 2 pi. Okay, this is f of theta, so 1 upon 2 pi you can write outside, this is, and it is integration 0 to 2 pi. So this is, you can write sine 2 theta square, this is sine square 2 theta, sine 2 theta is 2 sine theta cos theta, sine square means 4 you will get, so upon 4 you have to write. This is sine square 2 theta means 4 cos square theta sin square theta. So this you can write as sine square 2 theta upon 4 d theta, this is, and it will be equals to 1 upon 8 pi you can write, and integration 0 to 2 pi. Okay, sine square theta is what? 1 minus cos 2 theta by 2, 1 minus cos 4 theta by 2, this is, and d theta. Okay, yes, and if you do integration and substitute limits, it is 1 upon 16 pi, 2 I am writing outside, integration of 1 is theta only, integration of cos is sine, sine 4 theta upon 4, limits will be 0 to 2 pi. Okay, and if you substitute the limits here, this is 1 upon 16 pi, we substitute upper limit, theta ka place mein 2 pi, and sine 8 pi will be 0, so it is 0 minus, we substitute lower limit, that is 0 only, 2 pi upon 16 pi, that is 1 by 8. Okay, so expectation of x square y square is 1 by 8, and expectation of x square into expectation of y square, this is expectation of x square into expectation of y square, 1 by 2 times to 1 by 2, 1 by 4, but expectation of x square y square is 1 by 8. So you can say expectation of x square y square not equals to expectation of x square into expectation of y square, not equals to. So here option B is not correct. And what about option C? Okay, the variance of x is variance of y. Yes, you can see what is the variance of x here, you can write expectation of means x square minus expectation of x whole square, you can write. Okay, expectation of x square, how much we got? 1 by 2 na? So this is, and even mean 0 we got, expectation of x is 0 we got na? This is, mean to 0 hai, mean 0 means mean square value equals to variance, variance is mean square value only 1 by 2, variance of x is 1 by 2, variance of y also of course 1 by 2 only you will get. So this is option C is correct. Okay, so here A, C, D will be correct, A, C and D. And if the question is x and y here are independent or not, independent to nahi hai. If x and y independent hai to expectation of x square y square also should be equals to expectation of x square into expectation of y square hona chahiye. Okay, not only for first order, for every possible order this equality should hold good, then only you can say x and y are independent. Here for second order ke liye the equality is not holding good, so x and y independent nahi hai. Okay, independent to nahi hai. यस इंडिपेंडेंट तो नहीं है. Yeah, just by trying up to second order you will come to know like x and y are independent or not. You will come to know that. Yes, you can see here x and y are uncorrelated तो हैं because covariance 0 means uncorrelated. Okay, so random variables are uncorrelated but independent तो नहीं है. In the regular classroom I given this, if random variables are independent, if the random variables are independent, like expectation of xy is expectation of, if independent hai to this expectation of xy of course equals expectation of x into expectation of y, it will be satisfied. If random variables are independent, for every independent hai to for every possible order this equality holds good. First order ke liye bhi satisfied hoga. So if random variables are independent, this condition is satisfied. If this condition satisfied hai to covariance to 0 hoga. Covariance 0 means straight away I can say uncorrelated. So if two random variables are independent, then definitely will be uncorrelated, undoubtedly. But reverse is not true. Like you can see, if random variables are uncorrelated, covariance 0 hai to, then we can't give a guarantee that random variables are independent. We can't give a guarantee. Here you can see that. Okay, आप देख सकते हैं अनकोरिलेटेड है बट इंडिपेंडेंट नहीं है. इंडिपेंडेंट तो नहीं है. ओके, बट रिवर्स इज नॉट ट्रू. Yeah, Rahul Kumar, any telegram link to ask doubts, questions to you? Yeah, you can. You can post your doubts here. So Naresh Reddy, it is my telegram ID. You can post your doubts here if any doubts are there. So the time is not sufficient, so still some questions are there, but okay, I will post this remaining questions in the telegram in the respective groups, whatever the questions I left with, like the questions based on finding probability of error. The remaining questions I will post in the telegram, so you just do try those questions. The time is means the next the classroom is allotted for another session for another subject. Okay, so I will close the session, this GTQ session as of now. Some questions, few more questions are there, and I will try to upload those questions in the respective telegram groups. I created telegram groups for various batches, no? So I will post in the respective telegram groups. Okay, you can try those questions. Okay, so I hope the session which I took will be helpful to you. I hope so in the coming examination. So all the very best, guys. God bless to you. Thank you. Yeah, Ishita, I will. App में तो I'm not sure about that, but in the Telegram app में in the respective groups I will upload. Yes, in the last year 3 symbols के लिए by given 3 symbols they asked for probability of error. I discussed already that question in the YouTube में मैंने discuss किया है. So just check for gate solutions of last year. On the day of gate examination itself I discussed on the day of gate examination last year. So I discussed that question in the YouTube. So you can get that video solution for that question there. If you want to take the screenshots for the next questions, you can take. This is one question. Okay, you can try these questions if you want to. The answer for this is this, I think, and you can do check. So you can try this question. The answer I have not remembered. You can check. This one also you can try. Take the screenshot if you want. And this question, and this question. Okay, these are some questions. You can take the screenshots and you can try. ठीक है guys, I'm leaving. Thank you.